that okay? Thank you. Thank you. I'm sorry. There were some technical difficulties, but then maybe that's close to the topic I want to talk about to you today, which is predictability. Who would have predicted that this would happen? One, at least. Always. You're saying it's always happening.
I've seen this in Berlin as well.
Okay.
The technical issues in the beginning.
Okay.
Yeah.
So for you, it's like 2 out of 2. 2 conferences, twice happening. So this is the norm, probably. Yeah. Interesting. So. Yeah. Let's talk about the future, right? The future. It's the Saturday for future today. It's not the Friday for future. But it's a different future. It's the future of SAP development, I would say. No, it's not just the future of SAP development or ABAP development. It's the future of all software development I'm talking about today, at least how I see it. There is no alternative way into the future if we want to become more reliable in delivering software. And this is due to this question. Who has heard this question or a question sounding alike, like when will it be done? Who has heard that question? Yeah, okay, that's what I expected. See, I want to do a real popular talk. Everybody can relate to. And so this gonna happen again, or are you? Yeah, probably. Okay. So who has read this question? Who was asked this question? Are you doing something there in the machine? Not anymore. Thank you. Yes. Who answered this question happily? Great. Yeah, that's what I wanted to see. So this is a talk for you, because my mission today is that this question will not be asked you as software developers anymore. This is to be avoided. This produces dysfunctional software development. This produces stress. So but how? How then? I mean, because the question is there, it's a legitimate question. What can we do about it? It's a legitimate question because the people asking it are so different from you and me. They are concerned with budgets. They are concerned with priorities, with cooperations with other organizations. They are concerned about dependencies, which also has to do with cooperation maybe. So this is a legitimate question, and there was a time, a couple of years ago, where I thought, no, this question should never be asked. It's wrong to ask software developer this question, or software development in general should not be concerned with this question. And yeah, I was driven by this sentiment, this feeling, okay, of pressure. I don't want to live under this pressure. But then I misunderstood. Business legitimately asked this question. And we have to find an answer for it. Otherwise, there will always be friction and conflict. Okay, I'll have to watch my mark here on the ground. So, do I want to? That's what a manager wants to decide. Or not just a manager, also the simple product owner. Do you work in an agile manner in your projects? Some do, okay, few do, almost nobody does. Okay, anyways, so there is the customer or some representative of the customer somewhat close to you, and the closer it's getting to the deadline, the closer those people come and whip you. So what can we do about this? Unfortunately, literature has it that we cannot guarantee good results. Okay, that's what the manager is concerned about. If we don't know the odds, the probabilities of stuff. So if managers want to be good managers, if project leaders want to be good project leaders, if customers really want you to perform reliably, then they have to be concerned with probabilities. Did any of your managers, have you heard about this probability stuff? Anybody talking to you about that? I guess not. This is, I wouldn't say a lost art, it's not even a discovered art in software development to talk about probabilities, but we have to. Okay, so terminology. There's a few terms I want to introduce to you today. The first one is prediction. prediction is a very general term to me. Prediction just means, well, a statement about the future state of the world. So a prediction could have been, like before we started, Ralf will connect his laptop to the HDMI cable and it will show the presentation right away. That could have been a prediction. And the prediction would have been wrong, as we saw. Okay, but a simple prediction. Prediction is not about right or wrong, it's just a statement about the future. So when asking this question I showed to you, people are inquiring about a state of the future. Good, so let's have a look. You're rolling a dice, or you have a dice in your hand, or I have a dice in my hand, and I'm rolling it, and I'm asking you for your prediction. Sorry, there was a better font on my machine, so this is running out of the projection here, sorry. I'm asking you about your prediction. What will be the sum of the next two rows, or what will be the next two rows? What will be the sum of the next two rows? What's your prediction? Any idea? 7. Okay. How sure are you? Would you bet 5 euros on 7? Probably not? Okay. So here's an explicit risk attitude here. Would you bet 50 cents, 10 cents, 1 cent? That's the question. I didn't tell you even what you could win. If 7 comes up, you win like 100 euros. Would you bet 10 euros? See, it becomes more difficult now. But that's what I'm asking about. Make a prediction. What's the next number to come up? And the next number might be 7, or it might be, what could it be? From 2 to 12. Okay. 7 sounds to be like somewhere in the middle. Maybe that's why he said it's probably 7. But how probable is 7? I don't know. So that's a question. That's a prediction. And what did he do? I think the answer was except for you really paid attention in math, except from that, it's just a feeling. I think it could be somewhere in the middle of this range maybe, or maybe you have some experience. So what the answer was, an estimation. And an estimation to me today at least is a single value. 7 was a single value. It's devoid of likelihood. He didn't say how likely it was that the 7 would show up within the next 2 rows. And it's maybe based on experience, maybe not. And usually cannot be explicated or quantified. So people who are saying 7, why did you say 7? Have you read that somewhere? Is that your experience? Can you calculate that? What's the reason you're answering with 7? Question, okay. But this is close to math, right? Let's have a look. What do you do usually for an estimation? For an estimation, you have a dark number of experiences you're not really clear about what your experience were. Maybe in the recent future you have very explicit and memorable experiences, and then from that all together you calculate, you have this gut feeling for an estimation. That's usually what's done. So what's the estimation? 7 was the answer. Okay, let's have a look at another example. So what's your estimation when this train connection will actually arrive in Helmstedt? It's planned to leave in Hamburg at 9:01 and arriving at 11:45, but given your experience with Deutsche Bahn, what's your estimation? What would you say, to somebody picking you up in Helmstedt? When should he or she be there? Around 11:45, or maybe at 11:30, or 12 o'clock, or tomorrow, not today? What would you expect? What's your expectation? What's your estimation for the arrival time? Interesting. So any idea? What would you say? Will this train arrive? Will you arrive on time? Who said yes? Who said yes? Are you a foreigner? You must be a foreigner. Okay, so
This guy wanted to say yes.
11:45, probably not. Maybe 11:46, 48, maybe 12:45. I don't know. So how do we come to a reasonable, and I mean reasonable estimation or reasonable arrival time? Let's look at our experience. There might be some dark experience. We have done a couple of travels to Helmstedt and we don't quite remember very clearly, just there was a delay, and then we have very concrete experiences, those two connections here, leaving at 9:02, 10:23, arrival in whatever, Hanover maybe, then this train leaving somewhat late, arriving somewhat late too, and this one leaving late, and then arriving 4 minutes later. Okay, so that was an experience. We recorded it maybe, but what to make of it? Question. Or this. Now it's becoming magic. There's a software development box, a magic black box, which does software development. You feed it with issues in a GitHub from a GitHub repository, and it's delivering releases to a GitHub repository, and it's doing this like all the time. You feed it a new issue, it produces a release, great, with quite high quality, not too many bugs in there. So how long it's going to take? When is your project finished? Having this black box, it's for free. There's an international association giving this to suffering companies, and so no developers need it anymore. There's only one drawback with this black box. You cannot ask when will it be done. Will a product owner like to use this black box instead of a bunch of developers who he can whip and ask when will it be done, and they are throwing out some estimation. What's your estimation? What would you look at? And you again would look at some dark experience, you're not very clear about the experience, and maybe some recent examples of when stuff got delivered. There was a feature started on 30th of October and delivered on 1st of November, another feature on 31st of October, delivered on 5th of November. Okay, yeah, that's some recent experience, but the next feature, the next 10 features, the next 15 stories, when will be they delivered? What's your estimation? That's the question you get asked. And you're answering with a gut feeling. And it's not going to work. Because experience, maybe not science, but experience also tells us this. An upfront relative size estimation, well, has almost no correlation to the total amount of elapsed time, which I call cycle time, that it takes to complete the feature or the feature set. There's no correlation. No correlation. I can only repeat that. No correlation. It's just a wish. It's not reality. But this is what you get asked. Give me a number. Give me just one number. It's not going to work. Okay. There's lots of problems with estimations. I guess I spare you reading them all. They are on the slides, and Peter happily will send you the slides, some link to them. Okay, you can read them all. The bottom line for me is estimations are highly inaccurate. I mean, what would be an accurate estimation? You say 10 days and maybe it's 11. Maybe that's accurate, 10% delay, but usually it's 20 days or 25 days. That's not very accurate. Not worth a serious manager's attention because there's no risk attached to that. He can't really make an informed decision and immediately produce stress because you get fed a deadline, because you are telling yourself the deadline. Or maybe it's getting even worse because your project lead, you're telling him 10 days and he's saying, no, I know exactly, it's just 9 days. So there's the deadline. What are you doing then? Heads down, hacking away, and taking all sorts of shortcuts. This is a recipe for disaster. This is a recipe for technical debt. Right away. Okay. That said, you have this sense of a problem now. You have a sense of urgency. This needs to change. I don't want to live on all this pressure anymore. Okay, what can be done? Can be done. What can we do about this? We need to model things probabilistically. Yes. we need to model them. That's an explicit activity, and it needs to be done probabilistically. Yes. So there's probabilities involved. So we need to have a source where we can glean probabilities from in the first place. And the answer for me is in this word, which is different from what we heard so far. It's not estimation, it's forecasting. And the background image here is to illustrate what forecasting for me means. It's like in weather forecasting. Can you ask the weather, like the weather god, what do you think, how long will it rain? What's your estimation of how long it will take until all the water is drained from the clouds? Has anybody ever asked a weather god? Not really. Not in the recent history, I guess. So what do people do instead? What do they do if there's a hurricane brewing somewhere around here? What do? They make a forecast. They make a forecast on the basis of actual data, on the basis of experience with how weather patterns develop. We can forecast the temperature for tomorrow or the next 10 days based on our historical data we have about climate, seasons, the actual weather right now. We can make a pretty good forecast for that. And that's not a gut feeling, it's a calculation. So that's what I mean by forecast. It's a prediction, yes, again, like an estimation, it's a prediction with a range of values. Look again at this. See, there's a range of values where the Katrina hurricane can hit the coast and what his trajectory is from today until, well, sometime in the future. There's a range of values. Okay, and each value in this range has a likelihood attached. So some things might be more likely, more probable than other things, other outcomes. And it's based on factual data. There's no gut feeling. And it's calculated in an understandable and replicable way. So you can actually show how you came up with the numbers, with the range that you are presenting to somebody. And this then can be discussed, whether it's a good idea to do it like that. So that's forecast. And then I want to show you forecasting with a so-called Monte Carlo simulation method. What is that? Maybe you have heard that. Sometimes that's part of the computer science curriculum to do Monte Carlo simulations. It's repeatedly calculating simulated values, like where is the storm gonna be tomorrow and the day after, or how long will it take to deliver the software, to repeatedly calculate such values from random samples. From the historical data, you pick data randomly according to its underlying probability distribution, and then generate from that possible outcomes. Maybe it sounds a little bit abstract here, but we'll see how this is actually working in a concrete example. Let's look again at the dice rolling here, and this is the actual historical data. I rolled the dice 19 times, and that's what the number was that showed up on top of it. That's historical data. Now let's take this historical data and make a prediction, well, make a forecast for the two rolls. Let's take a first step, a simple step. What is the next roll? Just one gonna be. That's easy. We look at the distribution, the probability distribution of the numbers. There's just 6, 1 to 6. How often did they show up? 1 was 4 times, and 2 was 3 times, 3 was 3 times, and so on. 6 was just 2 times. What's the probability here? It's 0.21, 0.16, and so on. What should be the probability for each of those numbers? You know that? Sure you do. 1 divided by 6, which is something like 0.1666666, and so on. So almost 0.17. Okay, so this is close to the expected probability. This is higher than the expected probability. This is lower. That's what we can see here. in this histogram, and we see, this is strange, they're not all the same. They are not all the same. And why is that? Why is that? Why aren't they all the same? Two reasons. One, this is just a limited sample, right? It's just 19 rows. We should have done 1,000 rows or 10,000 rows maybe. And the other reason might be this is not a fair dice. You never know. So you better don't go with math with the concrete dice, but better go with your concrete experience with such a dice. Maybe it's loaded, maybe it's not fair. So taking this, I would say, for the next roll, maybe you should bet on either 1 or 4, and not just any number. This is not Monte Carlo yet, now it's Monte Carlo. For the next 2, what would I do? I could have calculated this, yes, we can do that with math. If it's a fair dice, yes, and all probabilities are the same. But with this loaded dice, maybe loaded, I don't know, with this concrete dice, I'd rather go with the actual probabilities hidden in the historical data and simulate the outcome. So what do? We do a simulation run, number 1, and we pick randomly this historical data item in that historical data entry and sum this up, and it's a 6. We do this again, 5 and 3, it's 8, 6 and 4, 10, and so on and so on. So it's 5 out of 10,000. Or maybe 1,000, whatever. That's simulations. We're picking randomly from our observations, calculating the value we want to see, and then then we come up with a distribution again, and as we see, you were right. Number 7 is the most probable one. Interesting. Even with this maybe loaded dice, it's the most probable one. But it's just not very probable. It's the most probable one, but even the probability of 7 is just 0.172, according to the simulation. Well, you better don't bet on the number 7 coming up, right? So what this shows us that 7 is the most probable one. It's still not a good game to play, I would say, but you can look at another number. See, this is the one to bet on, but there's another number like 9. You could ask, how likely is it that a number from 2 until 7 or 8 or 9 is coming up? And that's a different probability. The probability of a number 9 or smaller is 0.878. Okay, that's maybe a good game to play if the rules were that way. That's a Monte Carlo simulation, very easily done, okay? Forecasting. And if you compare this to math, well, it's not bad, right? This is our simulation. You see it's the 7 with this most likely or highest probability, 0.172, and the math value is 0.167. Very close. Okay, so that as a validation of the method. And now let's move on. What about the train? Can we simulate the train arrival? Yes, we can do that. That's the actual arrival times, a history of 10 such connections or journeys. And I extracted from that the departure delay. When does it leave in Hamburg? Actually, sometimes it's 14 minutes late, sometimes 19 minutes. Arrival delay, sometimes it's 29 minutes late in Hanover. When does it leave from Hanover and arrive in wherever we have to change. And then the train to Hampstead sometimes is 18 minutes, 20 minutes late. So that's historical data. And we do the same with historical data here and grab from that random values and to form new possible future connections. And that's what we get. There's a premise here, an assumption. It takes 3 minutes to change at the station, to go from one train to the next train. And if you miss a train, the next one is leaving in 60 minutes. So schedule time. So you get a next connection. You're missing the one at whatever in Hanover at your expected time. So in 60 minutes, there's the next one. Given those assumptions, that's what our probability distribution looks like. see the peaks here. This peak is after 60 minutes, and then there's 120 minutes. There's a drop here, but we have all from 0 delay up to 138 minutes delay. It's all possible. And so what would you tell somebody who wants to pick you up? For example, I expect with a likelihood of 0.574, 50% of the time I will be 61 minutes late or less. You can bet on 20 minutes here, right? Okay, that's in 40% of the times, journeys, 40% I'm 20 minutes late or less, but never 35. Why not 35? Because there's only the 60 minutes between the next trains. If you miss one, you really have to wait quite a long time. So it's 20 minutes max late, then either it's less or it's 60 minutes or more. Or if you want to be really on the safe side, you maybe tell them, okay, it's probably 32 minutes late or less. So pick your time, pick your schedule. When are you gonna take a train? What do you expect? When can you arrive at a meeting in Helmstedt? Actually, I've talked to the Deutsche Bahn about this. I know a guy who's working in software development there, and they have this open data policy, so publishing their data for people to use for their apps, for the iPhone apps. And I talked to him about that. He said, yeah, that's very useful. But we have a high up decision from managers not to do that. We can do that. We know exactly where each train is at any time, but we are not allowed to publish such distributions for people to actually plan their travels better. Too bad. Okay. So I'm thinking about this crowdsourcing thing. Come up with people who are actually watching the trains in each station and gathering the data for the public to use. So maybe SAP will help with a little budget there. I don't know. So what about software development? This is what you were really interested in, right? Was just foreplay. Was just trying to sell you the method of Monte Carlo forecasting. Now let's apply this to software development. This is the historical data. I think it's 35 entries in the backlog or in the issue tracking system like the GitHub or whatever you're using. So it's 35 issues that got started and finished, which are classified in some way. Some are bug fixes, some are feature developments in the back end or in the front end, and there's a story attached to them. So story 3 led to a couple of issues here, story 5 led to a couple of stories, and the cycle time. So starting on 14th of October until 16th of October, that's 2 days cycle time. Okay, that's historical data. Or maybe it's also hysterical data, I don't know. What can we do with that? Let's have a look at it. This was the actual development. This is the work in progress. Wow, so much work in progress at the same time. Lots of issues in the system which got worked on, 7 in parallel. Sometimes it's just 3, sometimes just 2, and sometimes 4. So 2 got loaded into the system, then another 2 got loaded even though the first ones weren't finished, and so on and so forth. Well, maybe that's a good idea to do it like this, or maybe it's a bad idea. I don't know. It's just reality. That's what we measured. That's what we logged into our system. Okay? I don't want to bore you too much with the terminology. It's just story. Story is on top, a bigger thing, and the story gets actually broken down, refined into issues, and for the issues we actually track. When do they start? When do we start working on them, and when do we finish working on them? And we don't do that on the next higher level, on the story level. Okay, so let's forecast how long does the next issue gonna take. For that, we just look at the probability distribution of the cycle times. It's one more issue. We look at the cycle times and we see, well, most probably it's gonna take 2 days. Just any issue. Don't qualify that any further. It's just the next one issue. It's probably taking 2 days. But how probable is that it's going to take 2 days? Well, as you see, it's not very probable in itself. It's just not even 30%. How much would you bet on 30% success probability as a product owner? I don't know. That's like betting on next roll of dice is 1 or 2, but not 3, 4, 5, 6. I don't know how much one you bet on that. But then, if you want to really want to go with a real sure bet, maybe you bet on I win with 1, 2, 3, 4, 5. I just lose on 6. That's a good game, right? Would you bet $10 on 1, 2, 3, 4, 5? Yeah, sure. Okay. So that's a probability of 38% or 0.83, and that's almost this here 5 days, 5 days or less. It's 5 days or less for one feature. If you really want to be pretty sure that it can be done. Okay, so for a synchronization point, when should the presentation of the feature be? You want to invite some people. Okay, go with 5 days. Or be in for some very, very frustrating discussions about why isn't it done in 2 days. Okay, that was just one feature, not very, you don't see that very often. Most of the times you want to talk about multiple features, but let me just tell you one more thing about single features here. You can of course be more specific. This is single issues, very general issues, and we would go with the 5 here. But then if you look at single features, features are extensions compared to bug fixes. So distribution for the features looks different from the overall issue distribution and the distribution that's for the bug fixes. As you can see, bug fixes tend to be shorter than feature development. So it would be helpful to ask, well, the next issue, I mean, what is it? Are you talking about a feature that needs to get done, or do you talk about a bug fix that needs to get done? Oh, it's a bug fix. Okay, then maybe it's 3 days with an 0.83 probability and not 5 days. That's a question.
I don't have a question.
Yes.
I understand that I can forecast dice rollings because each dice rollings are the same. It's the same process. If you ask me how long does it take to implement a feature, it could be a small feature or a big feature.
Yes. That's what this range shows. It could be a small feature or a big feature. That's what this range is telling you.
So the first question I must ask myself, is it a small feature? Then it maybe it will be implemented fast, or is it a big feature? I cannot even put all the features into one pot and I can calculate with them.
Okay. He's saying he has to first classify these features according to rough size, like a t-shirt size or story points. We'll get to that later. I would answer at this moment, no, you don't have to. It's just larger variation. That's what I wanted to show you here. It's a larger variation if you are going with less classification. It's a smaller variation, or looks different as the probability distribution if you are more specific. You can even be more specific. It's a feature done by Peter versus it's a bug fix done by Bruce. So they all have their own history. You can be as specific as you like. But what you get is, well, maybe a wrong answer, because in the end it's not Peter doing it because he's sick and Bruce doing it. So you calculate it so precisely, you simulate it so precisely, but the reality is so different. So I would go with some variation. I wouldn't make it too specific. Go with the overall picture of software development. And this is just a start. Let me continue. So what with multiple features? What multiple issues? Now I took 8 issues 3 were back-end features, 1 was a bug fix, 4 were front-end features. So I mixed them all together, got a classification for them, and did a simulation. And this is how 8 features delivered by one resource, maybe a pair of developers or maybe one developer, how this comes out. And our likelihood here, our probability we like very much, the 83% for the 1, 2, 3, 4, 5 dice roll win is 35 days. Okay. And so there's a mix of features in there. And the mix of features was in the historical data and it will be in the future data. The mix of features in the history is the same as the mix of weather temperatures in the past. And you will see if you observe this over a longer time, there are seasons. And sometimes it's going faster and sometimes it's going slower. Why is that? Sometimes there are more people on the project, sometimes fewer. Sometimes a really important guy is sick. Sometimes he's on maternal leave. Whatever. There's lots of things going on. Or we are moving from back-end work to front-end work. So this is changing our season in software development. You have to observe that. But it's all so much better than your, Ralph's, gut feeling. Or your gut feeling. Or your gut feeling. Or my gut feeling. Gut feelings don't even provide this level of detail. Okay, so it's 35 days with one resource. Now throw at this 3 resources. It's 3 people or 3 pairs working in parallel, and you give to him one feature, he's starting to work. Then he gets the next feature, he's starting to work. Then you get the next feature, you're starting to work. He finishes, then he gets the next feature, pulls it from the Kanban board, ready for development column. And then he, and so on until 8 features got done. What's our simulation, how long that will take? Well, it's not 35 days or whatever anymore, it's just 14 days. How great. Let's do it with more developers. Let's throw more developers on it. Maybe 5 people, maybe 6 people. So it will shorten the time, ideally. Just ideally. Because this is expecting that work on a single feature really progresses in a very nice way, without any delays, without any dependencies, no waiting time in between. That's nice in a very, very controlled environment, where we really are a cross-functional team and can make all decisions and don't need to wait for anybody else. Okay, so but you see it's already getting better. It's 14 days with 3 resources. Great. Now, let's move on. And that's throughput based. It's not on the cycle time, but throughput is how many features or how many issues did get delivered each and every day. That's a throughput. And as we look at this, we can see this is the dates when features got started, or no, finished, and there was 1 finished on the 2nd of October, 4 on the 4th of October, and so on and so on. With weekends in between, we see sometimes no feature was delivered or no issue was finished. And then on the weekends, never anything was finished, so I compressed this here down to just working days, and that's the histogram we see. Most of the times it's 3 features per day that get delivered. That's the highest throughput. And very rarely it's 4 features or 4 issues a day. But 1 feature is also very common. That's the throughput. You could classify that again if you like, but I'm doing this without further classification. Taking this data, this is our cumulative flow diagram. You see the blue line tells you what flows into this system, what gets started to work on, and the yellow area here is what got finished. And you see they're pretty much evolving at the same rate here, right? This is how long a feature took until realization. This is how many features are in the system or issues are in the system right now. And the difference here, that's the throughput, shows how much gets delivered. Okay, if I do the forecast based on that, look at it. Ha, it's even better than saying it's 3 resources working on it. On the actual team, I don't know, maybe it was 5 people or 3 people or just 2 people, I don't know. But they managed to do it faster than the forecasted 14 days. It's just 10 days if you're looking at the throughput. So most likely 10 days or less, that's what I should bet on, probably the 0.849. Good, cycle time. That's 10 issues, no, 8 issues again, 8 issues. So, but we can go even further. That was single issues, right? This is not really what you want to plan on as a granularity level. You want to plan on the level of stories, or even larger, maybe epics, some larger stuff. And as long as you track how the bigger pieces of requirements get refined into issues, which you are actually tracking with each and every day, starting and finishing, then you can also model probabilistically how the slicing works, how big things get refined into small things. That's what I'm doing here. I'm looking at the stories. So there's 8 stories, and some stories get refined into 3 issues, some into 2, and well, some into 5. So that's different granularity. Some stories are large, and some are small. Did I get it right when I first estimated the size of a story? So here I said it's a large story, and indeed it becomes 5 issues. Here I said it's a large story, and I got it wrong. It's just 2 issues. And here it's a small story, and it was 3 issues. So there is some categorization involved, and you can ask that pretty early, the developers. What do you think, this story, large or small? And then you track how they get refined into issues which you are actually logging. So looking at that, that's the forecast we can do on the basis of stories. I simulated how 10 stories, I think it's 10 stories, including a certain amount of bug fixes and unclassified issues, get refined into issues, and most likely is 48 or less. And 48 or less means we're going to take 58 days or less to finish the 10 stories. That's one simulation. Okay, I pick a value from the refinement simulation and insert it into the delivery simulation. And yeah, I can do that. 58. But to be more honest, I should take all the simulations here for the story slicing. And for all the simulations of the story slicing, I should do a forecast how long it's going to take. And you see, now this is more realistically, and it's saying 60 days. And this was done like in half a second or even tenths of a second. This doesn't take really much time. So in tenths of a second, I can insert 10 stories to do, tell me how long it's going to take, 60 days or less, based on our current experience, how we did it in the past, with a given team, with a given, well, domain, and so on. And who got asked? Nobody got asked. But don't ask this question once, or don't do this calculation once as a product owner. Do this repeatedly, every time. So here I simulated 5 issues. 5 issues need to get done. It's the 6th of November, and I need to get 5 issues done. Okay, so what's my prognosis? What's my prediction? The forecast says it's the 13th of November. Sorry, you can't read the numbers here. It's the 13th of November. That's most likely that it takes so long or less. Okay, we start on the 6th of November. On the 7th of November, 1 issue already got done. I do another calculation with 4 remaining issues. How long it's going to take? Again, until 13th of November. Good, great. Let's move on. On the 8th of November, 1 issue got done, 3 issues remaining. How long it's going to take? Again, until the 13th of November. Good. Now things starting to change. 1 more issue done, 3 up there. It's 2 more remaining issues here, but there's 2 new issues coming up. Damn it. But that's how life is, right, in software development. There's no fixed scope. So for whatever reason, there's 2 more issues, so it's not just 2 remaining, but in total it's 4, and now we are at 7. It's not just the 5 from here, but 2 more, it's 7. And our schedule slips. It says the 18th, it's not the 13th anymore, it's the 18th. Oh my goodness. Okay, or what is, no, I think it's the 15th, the 15th. Next day it's 3 remaining, here it was 4, 3 remaining, but still it slips. It's the 9th, it's the 18th here. Then 2 remaining, but 1 more issue, 1 new one. Oh my goodness. Slipping to the 19th. And we continue this. 1 remaining, 2 more issues, again later. And this is the 21st now, 21st of November. And we're continuing, 2 remaining, 21st, 21st, so that's finished. Okay. This was a rolling forecast. Whenever something changed, one thing got done, a new thing showed up, I did a recalculation, I reforecast. And now, what about hindsight? At the end, on the 21st of November, when we were finished, what, with the information we then have, it's 10 issues, what if we had this information right at the beginning? What would our forecast have been? So let's do that again. Retrospective forecast, it's 10 issues, and the forecast is, lo and behold, also the 21st. We could have told the manager or whoever inserted the new issues on the 21st in the first place if we had known it was 10 features and not just 5. But we were so sure it's just 5, so we were optimistic in our forecast. Or no, not we were optimistic, that's what the forecast was. It's unemotional. There's no personal judgment in it. So you can do that at any time, right? Anyone who's able to use Excel or some software, see, this is the new area, this was our historical data. We worked through those dates here from the 6th of November until 21st. That's how the issues entered the system and were worked on. And that's our probability distributions at the beginning. Cycle times, here's our throughputs at the beginning, and that's how the cycle times ended, how they looked after we finished the additional 10 features, how the throughput changed. And you see throughput 1 was not the highest throughput before the 6th of November, but in the end it was the highest throughput. Okay. So we get actual data, we get the history of data, and this is, to me, all the benefits of forecasting. It's based on factual data. There's no gut feeling, no argument. Why are you estimating 10 days? What is it? I mean, are you crazy? Shouldn't it be 9 days? No, that's my opinion. Okay, he's entitled to his opinion. You are entitled to your opinion. So what then? Okay, this is a reason for fighting factual data. You can't argue with reality. Can then by anyone, and this is really important for me. A forecast, a prediction should never be done by you as a developer. They always should be done, whoever is asking for the numbers. Do it yourself. Do it yourself, man. You as a product owner, you want to know a date, fine, calculate it for yourself. Don't ask me. And from that comes, developers can assist with tagging or with classification. From that comes that the developer should not even know the deadline. And that leads to a different development cycle here. I clearly see that the development cycle is focused on quality without knowing any deadlines. Developers categorize stories or issues. That's the tags in the long history. They produce functionality and efficiency, that's what you're doing today, but also productivity. That's what clean code development is about, long-term productivity. So you're producing all the qualities which are needed for software development, for software in the long run. You're just focusing on that. You're never focusing on time. That's the responsibility here of the guy with the tie. He's responsible for value creation, so he's doing his prioritization, the granularization, so cutting features smaller and smaller into issues or stories into issues. He's doing the forecasting anytime at night he wants. We don't care. And he's to define the requirements in the first place. And then from whatever development produces in this cycle, iterative development, whatever development produces with all the qualities needed, he is labeling his releases from, whenever he likes. Whenever he thinks there's enough value for another release, great, let it from the release candidate stream created here, and never tell the developers any deadline, because as soon as there's a deadline looming, developers lose on those qualities here. They are just producing face value functionality, but they're not producing long-term productivity. So that's my case for forecasting, to decouple the number, the deadline, from developers and base it not on developers' gut feeling, but on actual data. Thank you. I know, wow, it's 10 sharp, right?
Yeah, but
it's
we
not C sharp.
We have 5 more minutes
5
for
minutes for
answering questions.
Okay.
Come on, guys. What do you think? You like it?
Oops. Yeah, right. If you want to read something, there's lots of things to read here, books and articles and so on. Yeah.
Is there a tool for managers that want that? Is that like a software?
Right, there's tools, yes. You know Joel Spolsky? Okay, no, that's a different community. He built a tool called Fogbugs. It's a bug tracking, issue tracking tool, and he built something like that into that. I'm not 100% on his side what his approach regarding his approach, but he's pretty close to that. Yeah, so that's the tool you can buy. There's other tools you can like rent online services. The guy Daniel Vacanti who wrote those books, highly recommended. He has a platform where you can do that, or you could build the tools yourself. That's like 1 day's work, and you're done. So it's a nice exercise to do that in ABAP. Yeah.
Hello. Okay,
I've code for that in C# if you like. I mean, I can share that with you. Question?
Yes, I have one question. This was all about one team of software developers which are in a company on a regular basis doing bug fixes and building new features. How if I do a new implementation of SAP, I have a new team, and so I have no experience with this team. What would you recommend?
What can you do? I mean, you can look at the past experience with new teams.
Yeah.
So what happened with new teams in the past? What did they do? One thing you can do. And there's, of course, a very, very, very rough estimation. You know that programming the next, I don't know, calendar is less time than the next CRM or whatever. So you have this rough idea. And then why don't you suggest, dear customer, let's do it for 1 month and see how it goes.
Yeah.
And then we get this historical data, and from that on we can base our
Forecast.
One more? Okay. That's one.
Don't you still have gut feeling, the developers, for like classifying the issues, like the t-shirt sizes or story points of the issues?
That's fine. Yeah. if you're not just classifying, well, this is in the back end or the front end, this is, I don't know, in the domain, or is a bug fix, that's very easy to classify. You are entitled to a gut feeling. That's perfectly fine. But I won't nail you to your gut feeling. Say, oh wow, your gut feeling was 8 story points. Aha, so let me see, 8 story points last time was 4 days. Now it's going to be 4 days again. And I'm wrong, it's 5 days, or 6 or 9 or 2 days. So to me, this is just a statistical correlation maybe, which shows up in the forecast. If you said 8 or 10 or t-shirt size, medium, large, whatever. I'm putting that in, and maybe there's some value to that, or maybe we see it's like random. It's like rolling a dice. Whether he says 8 or medium, we actually don't compare. It's no predictive value in that estimation. But why not us? That's just fine.
This is in the perfect world. So the most projects are budget driven or time driven.
Right.
So how we can work
I'd ask you, what's the difference? I mean, do you program it faster if it's budget driven?
Yes, they will lose any quality. Maybe.
Let me ask again, do you
Yeah.
program faster if it's budget driven, whatever that means?
Not
If you answer
Also
yes,
faster?
so I would ask, why do you have to be budget driven to program as fast as you can? Why don't you do that all the time?
I do have the answer.
You have here's the answer.
I do have the answer.
Yes.
When I'm budget driven, you will have an application and a budget, and
Yeah.
if it does not fit, we say, okay, we don't do unit tests.
Yeah.
We don't do
Right.
this, we don't do that. And then it will be fit
That's-
in the budget. That's
just,
because I'm faster.
Oh yeah. No, the other way around. I'm sorry. Let me
Because
just go
I'm doing
back.
not the whole thing.
Right. What you're you're taking shortcuts. You are focusing on this and not doing this and not doing that. Or you are focusing on this and not doing this.
Yeah.
That's fine. That's perfectly fine. Just know that you are cutting off the branch you are sitting on. Tell that your manager. And there's, as I heard, in litigation cases when there's actual, like, people sue you because you're not delivering on time. So there's a question of whether you did state-of-the-art development. And you didn't do any automated tests, you get sued because it's not state-of-the-art.
Yeah.
So I would mirror that back to your manager saying, okay, you want to get sued, you want to pay the fine because we're not doing state-of-the-art development? Okay, that's answer number one. The other answer is do it the other way around. What's your budget? I don't care what the budget is. Do fixed price projects, that's great. Fixed price. The problem is not the fixed price. The problem is fixing the price to all of this.
Yeah.
So do it the way around. How many days do you have? 100 days. So I tell you how many issues we can do in 100 days, most likely. That's your budget, great. And then he is gonna choose which are the features. So the manager here has the can rule which features, which scope, which granularity, which priority, and so on. That's all just fine. And you do whatever you need to do as a professional. Tell him you can fire me, but you can't tell me how to program. And it's an employee world, right? You can get the next job for more money in another company.
Due to the fact that we have a strong agenda.
Okay, sorry. Yes. Thank you.
Thank you very much.